Hey, good morning, guys. Just check. There is one absentees, isn't it? Oh yes, lovely here. Now, first of all, long time no see. Happy Chinese New Year, and first of all, welcome you or wish you all a very healthy year of Tiger, and I do think we need to wait until we have chances to meet face to face. But lives must continue. So we have to do nothing but just continue the Zoom lessons because your ultimate goal for secondary school life is one of the very most important goal is on the DSE. So we cannot just stop and wait. But of course, we need to rearrange the order a bit by allowing more time. Just like while I have got the first time of doing such arrangement is that just wait until face-to-face lesson resumes. We would have the lab section right away to have a recap of what is learned. So this is what I would like to tell you about arrangement. And because of that, we would have the chemistry essay as well as your chem quiz. Okay, resume next week. Okay, chem quiz will resume next week. So we would not only test you something about the organic chemistry, but also some of the concepts in Form 4 chemistry, we will try to add it in between. Is that clear? So we have got two very important assessment. Of course, we would also add some self-check MC exercise to help you learn. I know that it will be quite boring, but simply because you have so much time either like at home, which means that you have much free time to do so. Of course, it depends on your willpower, right? Whether or not you have got enough determination to do so. And that is what our senior brothers in the past few years have been doing like this. Any questions so far? Do you understand? Do you understand what I've just said? Oh, slept. Oh, yes. Okay. So which means that maybe you just get used to that type of mode, right? In Form 4, isn't it? In Form 4, we also have such similar arrangement. So we must continue, right? So go back to the chapter 32. Go back to chapter 32. Okay, do not lie in the bed. Okay, it's time to wake up. Hi, can I spend some? Can I have a chance of seeing your face? Now, could you please turn on the camera and let me know whether or not you're just still lying on the bed? Hey. No. Just just turn on. How about the others? I just see you. How about the others? And when I will remember to comb your hair. Similar as late saying. Comb your hair, please. Oh, they put up. You just wake up. Oh, Lei Cheng, why your black your screen is still black? How about the others? I cannot see you. Hi, morning. Lei Cheng, do not pretend that you cannot open the camera. How about in the new year, right? Every time while we have got the chemistry lesson, you open the camera, let me know you are still alive. Now, I would like to show you this one. Just have a recap because last year we just have we are just too rushed, right, of doing the synthetic routes. So it's time to take a look on that. Now, I would like to show you on here about the exercise, right? You know that the whole process, you may need the best way is to tackle it by doing the lab. But sorry to say that we do not have such a chance for the time being. So just skip that and until here. Yep, until here. Have you all done that? This one? Let's have a warm up. Have you done that? Now, all right, so take a look on question 2. Consider foreign conversion. This one. Have we all done that? It seems yes, it seems no. Right? This one, question 2. Take a look. Everyone have got a chance. We start from class 5B first, okay? Zheng Xiuai.
Hello.
Yes, question 2, please. Which of the following combinations can achieve the above conversion? Anyone who can help? Now, first of all, please take a look. It's B. It's B. It's dot. B or dot. Now, the difference between B and dot is the step 2 where you use both sulfuric acid, but one of them is dilute, but the other one is concentrated. Which one is more suitable? And tell me why. It's B or D, boy or dog. It's different, right? Dog is the more probable answer. Why? Now, for the first step, you may know we are going to have a substitution reaction. In terms of hydrolysis, right, to form this substance. So you may get to know this one. It seems like interlinking pentagons. So you may have got this. So we have got hydroxy group replacing the bromo group. So what is left behind is on removal of the hydroxy group with the neighboring hydrogen. Okay. So you know it is dehydration. So dehydration reaction would use the dehydrating agent for help. So concentrated sulfuric acid is the answer, but not dilute. Do you understand? Do you understand? Okay. So question 3 from Gahi. Consider following organic reactions where P, Q, and R are the major organic products formed. Which of the following combination is correct? But this one seems more manageable, right? It's C. Somebody say C. Now take a look on this. LiAlH4. How about the others? So I'm just say C. Now, indeed, what is missing? The concept left behind is on the use of LiAlH4. The answer is A in Z. So what is the difference between C and A? Is the step 1. Reducing agent. Lithium aluminium hydride is a very strong reducing agent. So all of you please mark it down. It's a very strong reducing agent, where it would directly reduce hydroxy group back to the primary alcohol. So that's why A is the answer. A is the answer. How about C? C, we need to have further steps to do so. For example, if you do such action in between P and the reactant with carboxyl group, you are going to add what? Acidified dichromates. Okay, acidified dichromates ions with simple distillation, with a very mild oxidation, such that you can go back to the aldehyde. Okay, so this is a very tricky one. This one I would like to get addressed to all of you about this. Question 4. Consider the following conversion. Now take a look on the change of the functional group. This is my clue. So the question comes, which of foreign combination of reagent can achieve the above conversion? Can I have Cyrus?
C.
C. Now, how many steps can we? It should be made. How many steps? Take a look. Yes, it's C. How many steps? It's not. Is it a one-step synthesis? Not really. Okay, we are going to have two steps. The first step, I use alkaline. Okay, is because this one would give you the is an irreversible change. It will allow the higher percentage conversion when you compare to the acid hydrolysis. So this one, it is hydrolysis. So in case it's hydrolysis, what will be the form? Cyrus, what will be the form?
If it's hydrolysis, it'll form a carboxylic acid.
Carboxylic acid, but how about in alkaline medium?
And if it's alkyl hydrolysis, it will form a carboxylate ion.
Yeah, carboxylate. So this is what you may find in carboxylate. And because of that, what you need to do is to regenerate it using dilute sulfuric acid. So you may get this. You may go as the carboxyl group. So it becomes a carboxylic acid. And finally, what's the next step? You want to make it as an ester. So the chemical should be the alcohol. So you may find this is the alcohol group. It comes from the alcohol, methanol. So, but the case comes, some chemicals is missing here. What is the chemical missing? What is that? Cyrus, what is missing here? In order to speed up the reaction, in order to maximize the yield, I need to add one more chemical in the in step 3. What is that? Ester.
Concentrated sulfuric acid.
Yes, consol. So this is this is what I would like to draw attention to this. Questions? Any questions so far? Now, warm up. Question 5. So the two-step synthesis, yes. What do you think? Sorry.
C.
B or C?
C.
B.
C.
B for boy, is it?
C for cat.
C for cat, sorry. So C for cat. Yes, that's right. So take a look on this. It is aldehyde. It's aldehyde. And it's not just aldehyde to be reacted with the hydrogen, but also the CC double bond. So the in between, the product should be this, because this one, they will react it with addition reaction. Or if you please mark it down. And but also this one, it is a reduction. Okay, so you may get this one, the aldehyde, go back to primary alcohol. So B or C is more possible, right? If you consider only step 1. How about step 2? Step 2, from P to Q, from primary alcohol, heating under reflux, underline the term heating under reflux, which means that a further oxidation will be made on the primary alcohol. So the answer is not stop at aldehyde, but also you go further to carboxylic acid. B is not the answer, because this one, it must come from the secondary alcohol. So B is not the answer. Is that clear? For those who cannot follow, could you please raise a hand? Let me know. All of you can follow? Question 6, 李晴. So I will just ask the questions in order of your class number, okay? So for the next students, could you please get ready? Question 6 is 李晴.李晴, where are you? Lý Chỉnh, slept?
Here. Sao我唔識做。
Now take a look on some clue about this, right? You have got that 2 chemicals. First one, what is the hidden message of this? It is what's the type of reaction actually? Heat under reflux from X to
Oxidation.
1. Yes, oxidation. So it seems like a prolonged oxidation. So you may get the concepts about from X to Y being something. I do not know, right? But don't worry. Take a look on the second step. The second step, we have got consol with ethanol heating under reflux.
Ester.
Yes, to form an ester. So the type of reaction is esterification. So you are going to think it in reverse. So it is ester. Okay, so it's ester. So trace back to Y. What can it be? Now, so you have got an alcohol here, right? So what is Y? It is
Acid.
acid, carboxylic acid. So carboxylic acid. So this is the one. So based on this, can you arrive at the answers? So C5H10. Now one more clue. C5H10O. So this one.
ketone.
Ketone, is it? Now ketone comes from the can ketone further oxidize to form carboxylic acid? It seems not, right? So X, it seems like a
Aldehyde.
what?
Aldehyde.
It's aldehyde.
X.
If it is the aldehyde, what can it be? It's quite strange, isn't it, right? So I don't know the true structure. I don't know the true structures. What is left behind is on the, you may take a look on step 2 again. So ethanol. So the chemical formula for ethanol is what? CH3, CH2, OH. So take a look on the ester having CH3, CH2O, right, as one of the, which comes from the alcohol. Which one is the answer? Now take a look on ester. Ester is not ester, right? It's ketone. How about this one? It's also an ester. Which ester we will call? We will have the group come from ethanol.
D.
D. So it is. Why do you know? How do you know? It's from by the naming, right? So the naming for this we call it what? Ethyl. We start from ethyl something. Right? So this is, it comes from the alcohol. So the answer is D. Now double check the thing is on this C3, 4, right? 5. We've got C5 H10O. Can you get my point? So what is X actually? Is it a ketone? You count the number for this, trace back to this. So CH2, 3, what is X? Tell me, is C5H10O? C5H10O. What is X? Anyone who can help? Yes, it's CH3. Somebody you say that is an aldehyde. Is it aldehyde? Is it possible to have such, right? It does make sense. C5H10O. So X is an aldehyde. Questions? Does it make sense? It's aldehyde. C5H10. Oh, yes, that's right. Question? Find it difficult? Question 7.
A.
Question 7. You find it is A. Now, you may find this questions a little bit, it will be more difficult now because you are going to have a calculation, small cal again, on the percentage yield. So you may have got 40% yield. It's 40% yield. So you are going to trace back to the theoretical yield first of all. Theoretical yield. It should be more, right? So it's 10.8 gram over 40%. So we would get the answer 27.0 gram. So by doing so, it is just first 40% yield. Can you follow the question, the flow of the question? So you are going to have finally you can actually get it. It is actual yield is being 10.8 gram. So we have got a theoretical yield being 27 gram. Remember to make a discount for that, okay? 60% off. So you may have got by doing so, you have got this. So based on the theoretical yield, you are going to trace back to the salicylic acid needed. Salicylic acid, 水杨酸. Now this is it comes from it can come naturally from some organic matter. Do you know where is it? Cyrus, do you know? Salicylic acid, 水杨酸. Do you know where it is? You may check it on the web as well. So where is it? It can come naturally from willow bark. Do you know what's that? Willow, 杨树. So the bark, it is the outer layer of the trunk, the 樹皮. So in the past, people, especially in Western places, in case they find something painful, so they would have a traditional wisdom by chewing those willow bark. And later on, the scientists will finally find that there is one chemical, it is the salicylic acid, which will help reduce the pain. So that is the start of having a Western drug, a very authentic example. So you use this from to get this. So based on these two, you may find the aspirin being having a mole ratio to salicylic acid 1:1. So what can be done? Yes, is to have a conversion. You're going to find to trace back to the theoretical number of moles of salicylic acid. It is equal to that of the theoretical yield, a theoretical number of moles of aspirin. Okay, aspirin, RC public. So it is a very typical, authentic painkiller, okay, to reduce fever, to reduce inflammation. And nowadays, while in COVID times, there are some saying asking somebody to take aspirin in order to reduce the chance of blood clotting. Okay, do you know what's that? Patient, will you know what's that? So because of that, yes, you know, yeah. So this is what you are going to do, right? So aspirin, the molar mass, it is 180.0 gram per mole. So you are going to get the number of moles. At the same time, how about salicylic acid? So we have got that the mass of salicylic acid, okay, over 138.0 gram per mole. And I use this to do the calculations, and you can get the answer. It's 20.7 gram. Is that clear? Okay, questions? You find it okay, could you please put a check? If you find still not okay, please put a cross. Let me know. How about the others? Okay. Now question 嚟答聲。
boy 啊嘛，
It's boy. Yes, that's right. It's boy. PI3. PI3 can do such conversion. My question, why not C?
佢好似係唔可以用 consol， 佢要用嗰個 con phosphoric acid 先可以做用咯。
Why can't we use consol? Consol. Now, if you recall the memory about the redox reaction, so NAI react with consol, also cannot react with consol. So what is the product? Redox. Hydrogen iodide can be formed, but very little amount. Why? So it will further oxidize by consol to form what? Iodine. So as the number part C is not so possible, because indeed the whole process, right, we are going to do is to produce, it's intended to produce HI in situ, but HI will be further oxidized by consol to form iodine. So the little amount of HI will make the substitution reaction possible. So number 3 is not the answer. How about number 1? It's also not possible because I2, it is a non-polar substance. It will be quite difficult to remove the hydroxyl group being polar. So can you get my point? So number 1 and number 3, they are not possible. Number 9. Who's next one? Taking off.
B.
Sorry. Number 9.
B.
A, B, C, D. Sorry.
Boy.
Boy. Somebody would say boy. Now it comes to the concept of preparation of salt. Okay, it is also possible to have number 1 and number 2. So it's quite difficult. It's quite difficult to understand for question 9. Okay, we will leave it. We may go back to the question later. The answer is D. Take a look on the flow of the book. Take a look. Indeed, if you are going to do the synthesis, okay, we need some very difficult steps. So in short, we have going to plan the experiment is also think of the reaction possible, and you're going to separate the crude product from the reaction mixture and purifying and calculating the percentage yield. So step 3 and step 4 is our main focus. How would you separate it and purify it? So it depends on the chemicals it is left behind or get mixed with the with your not only the reactants but also the products. Okay, so you go back to the following steps and you can get what I mean. So you may see the following. That is a setup. It can be reflux, it can be distillation, and you may see the techniques here. Separate and purify the liquid product. Do you see that? Having simple distillation, fractional distillation, you use separating funnel and drying. Now these two may be new to you. Separating funnel. Have you ever tried to use separating funnel? Now this one you may read it by yourself. You are going to get the simple distillation with the chemicals, with the target product having a much difference in the boiling point. Okay, when compared with the reactant. Okay, and second, be aware of the boiling point. It's not just the large difference. It's because of this part. With the lowest boiling point is most volatile, so they will boil first. A difference of more than 35. Okay, can you see that? If the boiling point temperature of a liquid product is very different from the other cooking mixture. Okay, of course, fractional distillation seems to obtain more pure substance, right? But simple distillation will have its advantage of being easy to set up, quicker to set up. Okay, but the product is not so the separation is not so fine when you compare with fractional distillation. So this while you compare with fractional distillation, so you are going to have a fractionating column. Inside that we have got some glass plates. All of you please mark it down. Glass plates. It allows a service for condensation. Okay, and at the of the vapor. So by doing so, it is a further process. So that whenever the vapor that comes out, it depends on the vapor. As you all know, it will get mixed with some other chemical of different boiling point. But inside here from the vapor, if you take a look on the liquid, when you compare with liquid and the vapor that would have a higher percentage of the chemicals. Now, why would I say it so general? Okay, chemicals. It can be reactant, it can be product, it can be solvent of lower boiling point. Now, just recall your memory about the fractional distillation of ethanol water mixture. So ethanol have a boiling point of 78 degrees, while water is just 100 degrees. So while even though we did not heat to boil water, some water will also be evaporated to form water vapor in the vapor state. No need to mention alcohol. Can you get my point? So the lower boiling point chemical will have a higher vapor pressure here. So this is the whole concept of distillation. And later on, this service, because we have got a gradient of heat being this. So it is hotter, it is cooler. So you may consider this part to have their own boiling again and again, like this. Okay, so by doing so, you are going to have the percentage of the chemicals of lower boiling point higher on top, while you compare with the bottom. Can you get my point? So it needs the help of the glass beads. If there is no glass beads, you are going to have the similar process as simple distillation, because the boiling and the condensation process is just one off. But here you may have got a successive. All of you, please mark it down. Successive boiling and condensation of the chemicals in the glass beads in the fractionating column in order to allow the better separation of that. What do I mean by that? Now, if you think, because this part, when you compare with these and this, we have got a higher percentage of lower boiling point. If you're going to talk about this part, you are going to make a further purifying of the product of having even higher percentage of the chemical of lower boiling point. And you do the same process higher, much higher. Can you get my point? And much higher until on top. 明唔明呢度講乜嘢? Questions? Do you understand? So the successive boiling and condensation would do it again and again, such that the most volatile liquid can be found on top. Okay, you see that some of the condensed liquid become vapor again. In this way, the mixture evaporating condenses repeatedly and it rises up, but at the very time that slow, the vapor become richer in the most volatile liquid present. It is the principle that I've just mentioned. Okay, but of course, if you want to talk about the time, now first of all, the advantage is that you are going to get the liquid of higher purity. So this is the advantage, but the disadvantage, it seems to be the advantage of having simple distillation. It's about the time of setup. The time for the distillation is different. But sometimes you cannot choose, because if you are going to tackle the separation of the chemicals in which the boiling point difference is rather small, this is the way to solve. Okay, Master, how about this? Separating funnel. Now, separating funnel is to use to separate the two immiscible substances. So, okay. So remember this part, you're going to whenever you see the word two layers, which means that it is immiscible liquids for separation. So you use separating funnel for help. Why? Because if they cannot get mixed well, simply by checking the difference in density, based on the difference in density, you may now remove the two layers. Okay, the one with a lower layer, they will have got a higher density, while on top, you know it is of lower density. It's by doing such. You're going to pour the mixture of liquid in a separating funnel. You're going to place stopper and try to shake to mix the contents, allow the layers to settle, place a conical flask under the separating funnel, remove stopper, and blah, 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 right? Like this, okay? If you find the process containing some acid impurities, you are going to add, now this is the one of the answer, okay? So you're going to wash it with sodium carbonate solution. So it is used to deal with some excess acid. So normally, while you prepare the organic liquid using acid, so acid is usually added as well. Catalyst, right? So you're going to destroy the catalyst by removing by adding sodium carbonate to react it. So because of that, once you are going to add sodium carbonate to acid, what will happen? Carbonate react with acid to form CO2 and H2O. Because of that, the gas pressure inside the separating funnel will set up. So you are going to open the separating funnel occasionally, okay, to release the pressure. Okay, and finally, you are going to further add sodium carbonate until there is no effervescence, which means that all acid impurities have all been removed. Okay, and you can do the further process. Now, because you are going to get mixed with it, shake it for quite a few, for some time, the product, you may find it some cloudy. If you find the organic layer is cloudy, milky, something like that, it may tell you it contains a trace amount of water droplets. Okay, so which will make the solution blur, which will make the liquid blur. So which means that you are going to dry the product. So how you dry the product? We cannot use Consol. Remember, Consol is an oxidizing agent, but also dehydrating agent. So all of you, please mark them. Consol cannot be used, right? Because it is quite reactive to organic product. So you are going to find some drying agents. Okay, just like anhydrous salt, you may see that calcium chloride, MgSO4, sodium sulfate, in order to dry the product. So this is what you may find it on statement 3. Statement 3 about the MCs. Do you see that? Step 3. So take a look on the questions. So the questions on here, it is on question 9, sorry. Question 9 here. So the crude product can be separated from the reaction mixture by fractional distillation. Okay, it's correct. The second, the crude product should be washed with sodium hydrogen carbonate solution. Yes, that's right, because we have got Consol. So you are going to remove the acid. Okay, the sodium carbonate, hydrogen carbonate is to remove the hydrogen ions. How about anhydrous sodium sulfate? Because during shaking in the separating funnel, we've got a trace amount of water droplets suspended in the organic layer. So you are going to absorb the water droplet in the organic layer. So this is the answer is D. Questions? Sorry to say that we don't have a chance of doing the lab for the time being. Now, so let's grab some chances while we meet. Magalop, question 10.
Boy.
Is boy. Yes, that's right, boy. The steps. Take a look on step 2. What can it be step 1? Can you correct it for me? Step 2 is correct. It is the R2072 minus, and then with unheating under reflux. How about step 1? Step 1 is what?
NaOH heat under reflux.
Yes, NaOH heating under reflux. How about step 3? Something is missing.
加 NH3 就得啦。
Yes, and what? NH3? Is Dutch NH3?
Aqueous ammonia.
Aqueous ammonia. What else? How about condition? Room temperature?
Heat under heat.
Yes, this is the key point. You are going to heat it instead of placing at room temperature. Otherwise, if you just make it as room temperature, it is just neutralization. So the product is ammonium salt, but not amine. Now, this is very crucial. Now, underline the term heat. Remember, for you're going to have a room temperature, you can never produce the amide. It's just neutralization. You're going to heat it. If you want to have a prolonged heating under reflux, then you can get amide. Question 11. Which of the following processes can form ethanol?
C, cat.
C, cat. C for cat. So heating ethanoic acid with NaBH4, what would be formed? No reaction. There's no reaction. Now, NaBH4 is a reducing agent. This is not powerful enough to reduce the carboxyl group back to primary alcohol. How about step 2? It is hydrolysis. Yes, that's right. And 3, what is that? Ethyl. Ethyl group, it is from alcohol. So by doing this, what is that? Again, it is hydrolysis. Okay? The reverse process of condensation this time to break down the ester linkage to form butanoates and ethanol. So C is a possible answer. How about 12? Which of our current compounds will react with sodium hydroxide solution to form sodium salt of carboxylic acid? So what's mean by that? You're going to add NaOH, NaOH, and NaOH. You're going to check the product and try to see which one will show a sodium salt of carboxylic acid. I don't know where you. Yes. Can I have question 2? That's 12. The answer is question 12. Now, which one will you know? Step 1, step 2, step point 1, point 2, point 3. Which one you know? Now, Tham Guan Yao and Wang Senghin, could you please tell me the product for step 1, for point 1, 2, and 3? Please help. Now, to start with, what should be done? Excuse me. You're going to check the functional group, exit, ester, amide, with any which it will undergo different chemical changes. What can it be? Right, Phạm Quang Dầu, Hoàng Thành Hiên. You think it's A? A, number 1 and number 2. Oh, 1 is neutralization. 2 and 3 is hydrolysis. Yes, that's right. Number 1 is hydrolysis. So both, all 3, they can arrive at the answer. So neutralization. So the product, it is CH32 CHCOO minus Na plus 1 H2O is neutralization. Water is formed. Yes, 3 of them will give the salt. The answer is D. How about number 2? It's an ester hydrolysis. Alkaline hydrolysis to form what? What is the salt? Once again, you know. Anyone who can write the answers here? What is that? Number 3 is also hydrolysis. Sodium methanoate. Yes, the second one. Sodium methanoate. How you express the answer is that. How about the remaining product? It is propane mono. Okay. How about the third one? How will you get the answer, Mr. Chin? Is by hydrolysis, right? You separate the functional group into 2. How about number 3? You do the same step. It's a CH3, CH2, CH2, COO minus Na plus together with what?
NH3.
NH3, ammonia. Is it ammonia? So this is what I would like to draw attention. It's quite difficult for question 3, actually, because for the amide synthesis, the product is a little bit. It can be very complicated. Why do I say so? Suppose I have got this. I do this as example. So what can it be? So it's amide and together with CH3. What can it be? You do the same process. Together with this, what can it be? So it will form this. So I further magnify this part and you can get what I mean. So you are going to write something like this. You are going to have a hydrolysis. Can you get my point? So you may get this. So it seems like I add back the hydrogen to here. So similarly for this, for NH2, right, as a part of the part of the compound, it will form H3. You understand? So what is that actually, Mr. Chin? What is that? It's amine. But if I do the similar action, that type of hydrolysis I be as acidic, the answer is CH3, CH2, CH2, COOH together with ammonium salt. How about this? This is CH3, CH2, CH2, COOH, and this will become what? A very strange chemical, right? So what is that? It is a type of amine salt. All of you, please write down. That's why I said this part being quite difficult to some of you. Questions?
先生，我想問下咧，第二個嗰個係即係點樣？即係我唔明點解佢個 source 一定要係 H 即係我唔明點解唔可以係 HCOH 咯？即係嗰個位佢切嗰個位。
Which part? Question point 2. Is it?
Yeah.
That ester undergo alkaline hydrolysis. Alkaline hydrolysis. Indeed, NaOH. Whenever you talk about this reaction, NaOH, usually it is in excess. So what will happen? Indeed, you may think of having an acid and alcohol as a product. Because of the presence of alkaline, the acid they will form with salt. So it's not just simply an hydrolysis, but also the neutralization that will happen. You may think it is as a two-step.
咁呢係點解唔可以倒轉嘅？即係唔可以譬如話呢個係HOCH2、CH3 咧，點解唔可以係呢右邊嗰個係 salt， 左邊嗰個係嗰個 alkaline？
Oh, okay. That is another issue. What Li Ching has suggested is this one, right? Anyone who can answer?
咩？你右邊係由 alcohol 嗰 part 組成噶嘛，即係左邊係由 carboxylic acid 嗰 part 組成噶嘛，所以你拆翻出嚟都一樣係咁。
So how would you know that which part is from acid, which part is alcohol? It depends on the way to present the word COO. If I write in the condensed formula, it is COO, you mean this. Okay, so because of that, you are going to think it in reverse. Okay, you separate it. So it is from the acid. While this one is an alcohol. Okay, because the shape of this part, now think it like this one. Okay, you are going to remove this part and you are going to add acid hydrolysis product. Okay, is OH and the H, right? Hydrolysis, and altogether is H2O, right? And because of that, you may have this original two chemicals. So acid group is on the left hand side while the alcohol is on the right hand side. Can we have a chance of having alcohol, the right hand side being acid? Yes, you can. But the way to present the formula is different. It's not COO, it's OCO. Now, for example, if the chemical becomes HOCO, CH3, CH2, CH3. So which means that this part it is O, CO, CH2, CH2, CH3. But if I change it like this way, what is that? Is no longer an ester. Okay, it is an acid, carboxylic acid. But it is quite strange to present this substance like this way. Now, in reality, while you study chemistry, we would not present it like this way. Instead present it like HOOC to tell it is a carboxylic acid. But OCO, this type of substance can also happen. For example, now it's very special case, right? Only have this. Now it is another issue. If I write this, which means that it is CH3, O, C double bond O, CH2, CH2, CH3. While the acid linkage is just here. So you chop it here and think it in reverse. And you may find this part being come from alcohol, and you may know that it is from the carboxylic acid. Do you understand?
Oh, okay.
明啦嘛？
Thank you.
How will you judge which part is acid, which part is alcohol? 李晴 ，Can you see? 點㗎？咩唔？因為問你點樣嘛？點樣分啊？個 ester 嘅左手邊定右手邊邊個係 alcohol， 邊個係 acid？ 點樣睇㗎？
首先 locate 咗個 ester group 先，
係
跟住就
但係有兩個做法嘅。嗱，如果佢寫嘅 COO， 第一樣嘢寫 COO 啊嘛。如果寫 COO 嘅話，咁左邊係咩咧？左邊係嚟自於 acid 定 alcohol 啊
acid，
左邊係 acid， 右邊 alcohol。如果寫 OCO 咧，就調翻轉啦，就係左手邊係 alcohol， 右手邊係 acid， 得唔得？咁如果你話都唔清楚嘅話咧，你就將嗰個 COO 咧就特登寫開佢。跟住咧，好似頭先阿 Sir 個方法咁啦，原本畫個 bond 㗎嘛，拆咗個 bond， 跟住噏翻啲 H2O 落去。咁你明知嗰個 ester 原本係指 acid 同 alcohol 㗎嘛，咁其實有 CO double bond 個位咧就最似 acid 個位㗎啦。咁你咪加 OH 咯。咁一個單 O 個位就咁加 H 就得啦。跟唔跟到
？OK，
明係嘛 ？Now， what's the time? Oh, it's 10:10 now. Oh, sorry to say that we just have a consolidation only, but not teaching you so much in this lesson. Shall we continue next Monday? I check my schedule. I check that schedule and get back to you if we can manage to have it in the afternoon instead of at night. Okay? Any questions so far? So what we have covered is on the consolidation of the organic synthesis, but mainly we focus on the chemical reactions. Now, something have been covered is something new, is on the purification and separation process. So you may find some parts being covered in page 163 to 168. Okay, being covered that part. You go home and please read this one as example, and I will check one YouTube video for you to get to help to have a recap of this. What is that? So we come to the class practice in the next lesson together with the calculating percentage yield. Okay, and finally we come to the organic synthesis step. Okay, and we can finish the whole thing. This is what we will do in the coming Monday lesson, afternoon section. Okay, any questions? 仲未問 Two questions. Number one, from 0 to 10. Number two, what is the difficult part? let me know whether or not you have got anything to up. If not, just mark it new. Let me know. How about the others? Instead of writing the number. Okay, so much for that. Thank you for the time. And ladies, could you please resubmit your essay, right? Essay 1 and essay 2, you misplace the both files in the wrong place. So essay 1,
Okay.
essay 2 or 2, but you just exchange the position. Okay,
Okay.
that's a good file tip. Thank you. Okay, see you guys next Monday. Bye bye.